this example involves bringing together the graphs and equations of polynomial functions and matching them to each other. So what we can see here in I and III, we have linear functions. These would both have degree 1. In V and II, we have parabolas. Those would be degree 2. And in IV and VI, we have degree 3. Now, looking at the two linear functions here, they both move down from left to right, so making a snap judgment based on the leading coefficient is not the best way to go. Likewise, with the parabolas V and II, they both are opening up, so we can't make a snap judgment based off of leading coefficient. However, with the degree 3s, we can. IV, as you can see, moves up as you go left to right, and VI moves down as you go left to right. So this means that IV is a degree 3 polynomial with a positive leading coefficient. The only one that matches is P of x. So that is the function that would match with that graph. Since VI moves down left to right and it is a degree 3, it has a negative leading coefficient. That one must be G of x. I'm going to move on to the linear functions. Something that I haven't mentioned yet but is an important piece is the actual location of the y-intercept. Not how many y-intercepts the function has, because it will always have one of them, but it's the location of it. The location of the y-intercept at both of those is negative 3. And the two equations that must go with those linears are h of x and q of x. And we can see from the equation that they both have a constant term of negative 3. And a constant is just a term with no variable, it's just the number. That will actually be true for any function. The constant by itself will be the value of the y-intercept. So we can't look at the y-intercept to determine which graph goes to which in isolation, but let's take a look at the two parabolas. V has a y-intercept at 1, and II has a y-intercept at negative 2. The parabolas must be J of x and K of x because we have degree 2, and parabolas match with degree 2. Looking at the y-intercepts from the equations, J of x would have a y-intercept of negative 2, so that means it has to go with II. K of x has a y-intercept of plus 1, so it has to match with V. So we used positive and negative leading coefficients to match the degree 3s. We use the y-intercept to match the parabolas. Now we are left with the two linears. We can't use leading coefficient because they're both negative. We can't use y-intercept because they both have the same y-intercept. We need to look at the slope of these lines. So if we look at slope, it's something we look back in grade 10. Slope is rise over run. And to calculate slope, you need 2 points. Well, in I already have this one point, the y-intercept. I'm going to choose this other point right here. And if we draw a triangle out, we can figure out the slope of this line. Slope having the variable m. Counting, we are going from the left point, we are going down 1, 2, 3, 4, 5, 6, 7, 8. And since we are going down 8, that has to be negative 8. We are going over 1, 2, 3, 4. that would simplify out to -2 for the slope. If we do the same thing on triple I, I'm going to take this point right here, drawing that out. Our slope, we count our rise, we go down 1, 2, 3, so -3. We run by 1, 2, 3, 4, 5, 6, which would simplify out to -1/2. Now when we're talking about lines, the slope is actually the leading coefficient. So looking at h of x, one of the two equations we haven't assigned yet, we have a leading coefficient of -1/2. That matches up with the slope of triple I, so I must be h of x. Same thing if we go to match up the slope with q of x. Q of x has a leading coefficient of -2, which is the slope, so then I must be q of x.